So picture this. 9 out of 10 students walk into their Cambridge IT 9626 exam, look at a really complex question, and immediately make the exact same error. It's an error that quietly but surely cost them their top grade. Welcome to this explainer, where we're going to dive deep into how to avoid these common grade-killing exam traps. Today, we're treating every single visual like a massive full-screen blueprint for success, breaking down these concepts step by step. I'm going to show you the exact mistakes you're probably making right now and exactly how to fix them before exam day.
Okay, let's just dive right into it. Put yourself in the exam hall. You turn the page and see an impossible question staring back at you. Evaluate the use of mainframes in national census processing versus distributed networks. You've got limited time. The clock is literally ticking. What do most students do? Well, they panic. And then they immediately start listing off generic facts, falling right into a classic examiner trap.
Just take a look at this flawed answer we have up on a screen. Mainframes are big computers used for the census. They can handle lots of data. Now, if you write this, you're walking away with maybe 3 out of 10 marks. Why? Well, this is what we call the cold open mistake. It loses major points because it completely lacks contextual specificity. It just throws out a generic statement and entirely fails to define the key technical terms before using them. Examiners actually call this the mark killer warning zone because terminology confusion and a lack of contextual focus will sink your score every single time. Section 1. The PLJ framework. From flawed to flawless. But don't worry, we aren't just here to look at the mistakes. Let's systematically rebuild that flawed answer from the ground up using a proven strategy. Instead of relying on those generic cold open statements, notice how this visual blueprint uses the PLJ framework. That stands for point, evidence, explanation, link, and judgment. To methodically construct those top band marks, you need to start with a clear point identifying a specific use, like transaction processing. Then you provide evidence from the text. Follow that up with an explanation of the actual technical mechanics. Crucially, you link it back to the original context, like national census processing, and then you finish with a strong evaluative judgment. It's a systematic procedural sequence that totally eliminates any generic rambling.
So let's see how this builds into our next topic. We can perfectly map this exact same PELJ logic onto expert systems. A super common mistake here is just stating that expert systems are accurate. I mean, that is way too vague. Where's the evidence? By using our framework, you don't just state they're accurate, you provide real-world evidence, and you link it back to a specific scenario, like patient-centric medicine, where systems can evaluate customized tablet dosages. You're proving to the examiner that you know exactly why this technology actually matters in the real world.
And when an exam question asks how an expert system interacts or how it's created, whatever you do, do not give a cold open summary. Instead, you can walk right through this 6-step setup sequence. Step 1. Gather information from human experts. Step 2. Populate the knowledge base with those facts. Step 3. Create the rules base using logical if-then statements. Step 4. Create the inference engine, which basically acts as your problem solver search logic. Step 5. Develop the human-computer interface, or HCI, for the user. And finally, Step 6. Testing and iterating. Explicitly defining these components proves your deep technical understanding of the whole shebang.
Section 2. The 4-prompt logic. Digital divide and e-safety. Now let's tackle another major hurdle where students consistently drop a ton of marks.
To completely avoid what examiners call the specificity gap, you absolutely must anchor your answers using this 4-prompt logic. When you're asked about the digital divide, just ask yourself 4 quick questions. First, what is it? Define the specific cause, like a lack of infrastructure. Second, how does it work? Explain the actual technical mechanism that's preventing access. Third, where is it used? Connect it to a real-world application, like remote schooling. And fourth, why is it better or worse? Provide the practical consequence for the end user. This structured memory technique ensures every single mark is accounted for.
And applying this 4-prompt logic to data protection ensures you don't accidentally confuse similar concepts. A classic wrong turn students make is mixing up authentication and encryption, but with our prompts, you can clearly differentiate them. Authentication is the mechanism for verification, proving who you are, like using a fingerprint scanner at a hospital. Encryption, on the other hand, is the mechanism for scrambling data so it's totally unreadable during secure communications. Same overarching topic, totally different functions.
Section 3. Web authoring, the cold open coding mistakes. Let's shift our focus over to web authoring, because these very same mistakes frequently pop up in HTML and CSS coding questions too.
The absolute crucial point here is understanding how files link together.
A classic coding error on the exam is using an absolute file path linked straight to your local drive. Look at the top example on screen, d:/myfiles page33.htm. Now that might work perfectly on your specific classroom computer, but it will instantly break the second it's uploaded to a live web server. Instead, you must use a relative file path, just page33.htm, which is literally the only way the hyperlink will actually work in the real world. Trust me, examiners look really closely for this.
When you're structuring your web pages in the HTML content layer, remember that structural tags mostly work in pairs. Think of it like this. If you open a door, you have to close it, right? Structural tags work exactly the same way. You open them and you must close them with a /. You have the table tag for the overall structure, tr for a table row, td for table data cells, and th for headers. Forgetting to close a structural tag is an absolute guaranteed way to lose formatting points and break your entire layout.
Take a look at this flawed student answer. They were asked to write the HTML for a simple cost table, and they lost really easy marks by completely failing to close the table tag at the very end. But even worse, look at the first row. They incorrectly used a row span attribute when they actually needed a col span to merge columns across the top. Indenting your code cleanly is a game changer. It really helps you catch these paired tag errors before you hit submit.
Now, when you're placing images into your framework, keep in mind that the image tag is a rare special exception to that door rule. It does not need a closing tag. However, it absolutely requires two critical attributes to get full marks. You must include the src attribute to identify the file source and the alt attribute to provide alternate text just in case the image fails to load. Without both of those, your answer is incomplete. No way around it.
Moving from the content layer to the presentation layer, cascading style sheets, or CSS, follow a very strict syntax. Notice the structure on screen here. It consists of a specific HTML selector, like H1, followed by a declaration block. And a massive trap students fall right into is forgetting that this entire declaration block must be enclosed completely in curly brackets. Inside those curly brackets, you have your property and your value, always separated by a colon.
Another frequent trap is writing out incorrect CSS declarations. For example, if you are setting text color, you must always use the American spelling for the word color, C-O-L-O-R. Sorry to my British English fans out there, but the examiner will simply not accept the U. And when defining that color, you accompany it with a hash symbol and a 6-digit hexadecimal RGB value, like #FF0000 for pure red. Small syntax errors here will absolutely cost you easy points.
So what happens if you have conflicting rules? If you ever mix attached external sheet styles in your head section and embedded inline HTML styles on the exact same page, there is a strict hierarchy you need to know. Remember that the embedded inline styles will always override the attached external ones. Basically, the style closest to the element wins the cascade.
Finally, for our web authoring section, never confuse HTML styles with CSS classes. A super common error is mixing up their syntax. Classes define specific subtypes that you can apply anywhere, and in your CSS file they must be preceded by a full stop, like .red. Whereas default HTML styles, like H1 or table, stand completely alone without a full stop. Knowing the difference really shows the examiner you truly understand the presentation layer.
Section 4. The final exam success strategy. Okay, we have covered a ton of ground today, from mainframes all the way to CSS syntax. Let's bring all this analytical strategy together for your ultimate final submission checklist to guarantee your exam success.
Before handing in your exam, you need to run your answers through this checklist. Always verify you've anchored your written answers to the specific scenario in the question. Remember, no cold opens. Ensure your technical sequences, like that expert system setup, are logical and step-by-step. Double-check that your web authoring code uses relative paths, not absolute ones. And please scan your code to ensure every single structural HTML tag is properly closed.
So the next time you sit down in an exam hall, will you fall into the cold open trap, or will you use this blueprint to systematically secure your A star? The choice is totally yours. Now that you have the complete visual blueprint to stop making these critical exam mistakes, tell us, what Cambridge IT concept should we decode using our 4-prompt logic next? Keep practicing, and we'll see you in the next explainer.